Yeah, hello everyone. Today is our presentation on Animal Crossing, and our company name is SafeCross, and this is our logo. And and we are a group of innovation and design. Next.
Today, we are doing a project on the preventing wildlife vehicle collision. We all know that wildlife is an important part of ecosystem which help to maintain the balance in nature. Roads are almost the most ubiquitous human infrastructure. It directly affects on the habitats destroy for the construction and changing in the dynamic of the ecosystem they run through. So in search of a food, they come on the road and sometimes vehicle collapse with them, which leads to damage of vehicle, death of animal, and sometimes it causes serious injuries to the human. And here you can see other statistical data. In the Australia, kangaroo is one of the animal who have to suffer most around 83% in financial year 18-19. There are several research are defined like making a fence, signs of animals on the road, bridges, reducing slopes loader. But making the fence along the whole road is not. It's quite difficult. Manufacturing of bridge for a migration of a wildlife is expensive, and reducing shoulder slope is not possible for all the way. So we need to come up with the innovative ideas which should be less expensive, easy, sustainable, and more efficient.
Record shows huge loss of life and property every year. Animals cross road for various purposes. You can see in the picture as well. Wildlife and vehicle collision is one of the crucial traffic safety issue, occurring mostly at night time. Similarly, it is difficult to construct passes over and under to animals due to the structure of landscape and higher cost. Likewise, the existing preventive measures such as fencing, signage, and awareness could not be effective as expected. So there is always demand in market for right kind of methodology. In this scenario, our product virtual fencing has lots of opportunities overcoming such limitations of existing product. It could be economical using simple technology and saving energy. It can be used in high traffic potential areas even at night time. The problem is common all around the world, so it has durability over global market.
Coming to the diversion solutions, we have a Q method. It's 5 Is and the input and output method. So coming to the 5 Is method, we have to find the innovative idea for the existing problem, which is more common in nowadays. So because of this, we can decrease the accidents and we can also protect the ecosystem. And coming to the input output method, due to this pandemic situation currently, vehicles on the road has frequently decreased, and because of this, animal crossing is more frequent nowadays. But after this pandemic situation, the situation will be reversed, and there will be more vehicles on the road, and there will be more accidents causing in this year. So to overcome this, we can place a virtual fence. It works in such a way that when the animal tries to cross the road, it detects it using the IRS, and when it detects the animal, it alerts the animal by producing a high frequency sound and a high intensity light. And like we can't stop the animal from crossing the road for a long time. So if there are no vehicles on the road, the animal is free to cross the road, and it's also safe. So to make sure there is no car on the road, we'll be placing a sensor which detects the cars on the road, and it does not produce any sound when the animal tries to cross the road. And the fifth problem is the power generation. To make it more sustainable, we are using solar or wind energy. Solar wind energy.
So we got 6 diversion solutions which are given in the slide. So the number 1 is installing digital automatic brake for cars. Number 2 is using LED boards. Number 3 is using automatic tranquilizer guns. Number 4 is building overhead bridge. Number 5 is using underground tunnel. And number 6 is using virtual fence. Next. So now we will be using design boundaries by considering the fog convergence criteria. So now we got like the number 2, 4, and 6 as the best solution from this method. So now we will be doing the first iteration conversion process. So now here we will be comparing the 3 best solutions that we got from the previous solution. Next. The second slide is the second iteration conversion process. Next. And the third, it is the third iteration conversion process. Now, we got the two solutions from those process, and then the two processes are solution number 4, which is building overhead bridge and using virtual fence. Now we'll be conducting the weighted constant matrix to get the best solutions. So by using this method, we got number 6 as the best solutions, which is using virtual fence.
Okay, talking about the conceptual embodiment of the product, since we are using virtual fence here, there is no actual physical barrier that's preventing animals from crossing from side A to side B. So to detect animals, we are using a long-range PIR sensors, which can detect animals at from 26 feet at the arc angle of 110 degrees. So by this method, where when these only activate when the cars are present on highway. These are detected using speed detector radar. This communicates a microchip computer inside so that it can signal surrounding fences so that the PIR sensor signals activate. So once those activate, and if there are any animals present, the high frequency generate sound is emitted to the speaker so that for short duration of time, so the animals get scared away, along with the high power LED lights, so that the animals don't mistakenly cross the highway even by mistake when running away from the sound. Next. So talking about the product design specification, since virtual fences talk about the detection and communication capabilities, as I said before, radio communication is a main part of our product with high detection and computational abilities. When you talk about market identification of this product, a product with large range perimeters are currently less. These kind of products are much less in the market. So when we try to introduce this product, I think this kinds of product will be much more welcome. So talking about a physical description, it's about 100 centimeters height with a 25 centimeters radius of hollow cylinders which can fit in various devices. Now talking about the financial requirements, most of our financial requirements will totally work on the design and manufacturing of the product.
Green design in this project refers to the concept of controlling the negative impact of innovative products on the natural environment and the resource consumption in the process of design products. We are committed to use eco-friendly and recyclable materials to achieve economic and environmental benefits in virtual fence project. The product uses magnesium aluminum alloy as the raw material. The advantages are lightweight, good heat dissipation, and strong pressure resistance. At the same time, it easily occurs and recycling technology is relatively mature. The integrated circuits inside the product use nanomaterials, which are eco-friendly and are now widely used, easy to maintain and replace. In terms of social impact, virtual fence will not take up too much space resource, which will reduce the possibility of new products causing social conflicts. On the other hand, we use the infrared rays that are harmless to the human body for the virtual fence produced by the products to avoid the potential health risks caused by the product. Therefore, the product complies with the concept of great design. Next.
Now I'll be talking about the intellectual property. There are various products in the market like a tracking system, animal alarm, and GPS control with the same aim, but the methodology is different. In this regard, our product is distinct and innovative. Going through protection of intellectual property, we are concerned with the different design, so the virtual appearance of our product saves us with patent right. We have distinct and reflective logo to assign our trademark in the market, and there is no any similar design registered. Let me conclude our presentation here, followed by references. Thank you all.